Hello, I am VIJEINDRAN from Group 16, and I will be starting off this presentation for our model Food Recognition in Tourism. So in this presentation, we have prepared the introduction, the existing methods versus the teachable machine, the testing, the conclusion, and the future improvements we can do on our model. So these are our team members. We have SHREETHAR, Danish, myself, and DINESH. So starting off with the introduction, why do food recognition in tourism? Tourists will often try Malaysian foods such as popiah or char kway teow, for example, and not know the name or the recipe as they want to try to make it at home themselves. Sometimes they want to know the ingredients so that they can see if they are allergic to anything or not. Struggling to speak the Malay language, they do not know how to ask the locals on the ingredients or recipe. So the solution, to prevent this issue from further occurring, our team has decided to develop a machine learning algorithm using teachable machine, which will recognize pictures of Malaysian food. This will allow consumers to identify the food they are about to consume or purchase and give them the ability to look it up online for the recipe or ingredients. The model will differentiate Malaysian foods by analyzing the texture, colors, and various visible ingredients on display. This would not only help tourists, but Malaysia as well in spreading their food culture.
Hi, my name is SHREETHAR, and today I would like to talk about the existing methods available versus our teachable machine implementation. So first of all, the first and easiest way to detect food would be asked to ask the locals. However, there might be language barriers, and this barrier is even more apparent when both sides are not fluent in English. For example, Japanese man would want to know the name of the food that he's eating, but then he doesn't share a visual language with the local. Therefore, there's no way for either side to understand each other. They can consider using translating software like Google Translate. Um, However, these apps are not always accurate, and uh, errors could occur. Finally, we can use Google Lens to detect the food. However, Google Lens does not differentiate the food around the world. This is because Google Lens was trained on a huge data set, and it is too general to capture the specific information um, to differentiate between two dishes that look similar to each other. Let's say a Malaysian food looks similar to another dish around the world. Google Lens wouldn't be able to capture the necessary information, necessary features to differentiate it from another dish. For example, Malaysia's nasi lemak has spicy sambal, while Singapore's nasi lemak sambal is a lot sweeter, which would mean their ingredients are definitely different, even though they look almost identical to each other. Sometimes the name itself would be different, so people would look up the wrong food. However, we in our teachable machine implementation, we did it different. Neural network and deep learning. In 2014, efforts were made to utilize CNN, convolutional neural network, and deep learning uh, for detecting and recognizing food images. By optimizing these parameters, CNN was applied to these tasks. Researchers created a dataset of the most common food items to assess recognition performance. CNN demonstrated a much higher accuracy compared to the traditional methods based on support vector machines with handcrafted features and artificial neural network, which is also known as for feed-forward neural network. Furthermore, it was observed that convolutional kernel indicated color plays a major role in feature extraction. CNN also significantly outperformed conventional methods in food image detection accuracy. Also, our teachable machine has been trained with to only classify Malaysian food. This implementation uh, solved the previous problems because Google Lens was trained on a huge data set, and that could lead to errors. While our teachable machine implementation model were only trained using Malaysian food. Um, so this will make it easier to detect what type of Malaysian dish it is. Thus, it is easier to look up on the recipe and ingredients on the internet. That's all for me. Thank you.
Okay, so I am Danish and I will be presenting the testing procedure. So we have 12 class models here: popiah, laksa, kaya toast, nasi goreng, char kway teow, nasi kandar, nasi lemak, ayam percik, nasi kerabu, apam balik, satay, and roti canai. So we will test these one by one. Popiah, 98, 99%. Laksa, high percent as well, 80, 90%. Kaya toast, high percent when it's at the right angle. Around, you can see it go up to 85% over there. Nasi goreng, 70%, 80%. Char kway teow, it was at, I saw it at 90% just now. Here's the angle, yeah. Nasi kandar, around 70, 80%. Nasi lemak, 100%. Ayam, ayam percik, around 70% at the right angle. Nasi kerabu, a very high percentage accuracy there. Apam balik, high percentage as well when it's at the right angle. Satay, very high percentage. And finally, roti canai. High accuracy at the right angle. And we can see under the hood, we can look at the confusion matrix over here. And we can see the accuracy per class. And that is all for the testing procedure. Thank you.
Hi, I'm going to explain about future improvement in food recognition in Malaysia. So first, we plan to introduce more input function by adding aroma and texture sensors. This means our system won't just see the food, it will smell and feel it too, enhancing accuracy and making the experience more authentic. Second, we will significantly increase our dataset, incorporating more high-quality images. This richer database will enable our algorithm to recognize an even broader array of dishes with greater precision. Finally, our teachable machine will go a step further by accessing the internet to provide you with links to recipes and ingredients instantly after identifying a dish. This feature will not only help you to understand what you are eating, but also enable you to recreate these culinary delights at home. Together, this advancement will elevate food recognition technology, making Malaysian culture more accessible and promoting our rich food culture to the world. Thank you.
Okay, me back again for the conclusion. To sum up this research paper, food recognition can be a problem for tourists. Asking locals and using software such as Google Lens has its limitations. Teachable machines provide an innovative and reliable method for precise food recognition. They represent a groundbreaking approach to food detection capable of learning from data and accurately identifying food based on visual features. This makes them an invaluable resource for tourists to understand the dishes they are consuming, while also promoting the local cuisine such as Malaysian food to a wider audience.